Hello, everyone. Today we are going to learn our fifth method of proving triangles. So far we have learned side, 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 angle, side, angle, side, angle, and angle, angle, side. And we have learned that side, side, angle doesn't work all the time. Well, hypotenuse leg, while it's only two letters, you still need to know three things. Because to use hypotenuse leg, you need to know you have a right triangle. Hypotenuse leg can only be used in right triangles. So this is a special case of side-side angle because we have the right angle and then two sides that do not include that angle. However, because it's a right triangle, it's actually a special condition of side, 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 because we know the Pythagorean theorem in right triangles would allow me to find the missing side. So, hypotenuse leg says, if the hypotenuse and leg of one right triangle are congruent to the corresponding parts of another right triangle, the right triangles are congruent. So, the legs don't really matter which one is which because they can be kind of flipped. But they may be used as long as the corresponding legs are used. Okay, so you must establish you have a right triangle to use. That's our third piece. We still need three things. So, example 1. We are given that ABC and DCB are right angles. And we know that AC is congruent to DB. So that's our given information. Typically, when we know that the angles are right, we would next say that all right angles are congruent. But we want to try to use hypotenuse leg. So I am going to say that triangle ABC is a right triangle. And that triangle DBC is a right triangle. And the reason why I know they're right triangles is definition of a right triangle. We know a right triangle is any triangle with a right angle. These are triangles with a right angle. Now, if I've done my first piece, I know that they're right triangles. The parts that I was given that are congruent are my hypotenuse. Remember, in a right triangle, I'll draw this up here. In a right triangle, the side across from the right angle is our hypotenuse. And the other two sides are what we call legs. So I know the hypotenuse. So I have two of my pieces of information. I have that as right triangle and I have the hypotenuse. Well, CB is in both triangles. So therefore I can say CB is congruent to CB, which is reflexive. Sorry about my phone. And then, since I know those are congruent, those are a leg. So therefore, I can say that triangle ABC is congruent to triangle DCB by hypotenuse leg. And that proof's done. So here's proof number 2. I want you to pause and try it. And then come back and we'll go over it. So, to go over this proof, the first thing is that those two sides are congruent. Then it says AD is the perpendicular bisector of CE. That tells me two important things. First of all, it says AD is perpendicular to CE, which means that's a right angle and that's right angle. So I'm going to say, knowing that those two are both right angles, that triangle ABE or actually before I say triangle, I have to say the angle because that was given perpendicular. So I can say that angle ABE is right, and the angle CBD is right. And that's because definition of perpendicular. Then I can say those triangles are right triangles. So triangle ABE is a right triangle, and triangle CBD is a right triangle. And that's definition of right triangle, because we know we have triangles with a right angle. Now I only used part of that. It also says AD is the bisector of CE, meaning AD cuts CE in half. So that means that CB is congruent to BE. Which is definition of bisector. And then if I look at those triangles, I have that they're right triangles. I know the hypotenuses or hypotenusi are congruent, and I know corresponding legs are congruent. So that means that triangle ABE is congruent to triangle DBC by hypotenuse leg. And then I can say that AB is congruent to BD by CPCTC. Because once I know the triangles are congruent, I know all corresponding parts are congruent. Okay, one more proof for tonight, and then we'll do number 4 in class tomorrow. So again, I want you to pause and try to do it and come back and check your answer. Okay, so I'm not quite done, but I thought I'd pick up here. So my givens told me these two legs are congruent. I have perpendicular, so that means DBA is a right angle and CBA is a right angle, which means triangle DBA is a right triangle and triangle CBA is a right triangle. I then know AB is congruent to itself. So I have ABD is congruent to CBA. Oops, I labeled those badly. It should be ABC. A should go with A. So ABD and ABC are congruent by hypotenuse leg. Now I want to know that AB bisects angle DAC. Well, knowing those two triangles are congruent tells me that these two angles are congruent by CPCTC. So I'm going to say that next. So I'm going to say angle DAB is congruent to angle CAB. And that's by CPCTC. And then my next step is that AB bisects angle DAC because it's the definition of bisector. We're using it backwards here, but it's still the same thing. And then proof number 4 we'll do tomorrow as the warm-up to our classwork. If you have any questions, please bring them to class.